All right, so here we go. Solving linear inequalities in one variable. So first we need to talk about interval notation, because this is how we write our solutions once we've solved. And so interval notation looks like ordered pairs, but we use brackets or parentheses or some combination of each. So you know whether something is an ordered pair or interval notation based off of context. So that's how you know the difference, because the notation may look the same. So bounded intervals basically means you are between two different numbers. So when we solve inequalities, we're going to solve and get something that looks like the inequalities that are listed here. And then you're going to convert it to the notation in the first column there. And that's interval notation. So I recommend just having this handy, because if you understand what the inequality looks like, then you can give the notation. The key is basically if it's a less than, you use a parenthesis. If it's less than or equal to, you use a bracket. I think of the less than meaning that the endpoints are not included, and so you're curving away from the endpoint because you can't touch the endpoint. While if it's less than or equal to, the endpoints are included, so that's a hard wall that you can touch, and so that's why it's a bracket, because that's something you can actually touch. So that's how I remember these things. So closed intervals are considered if they've got brackets on both sides. Open intervals have parentheses on both sides, and then you can have a combination of bracket and parentheses depending on the symbol. Unbounded intervals are where we go on to infinity, basically, that we're greater than a number or less than a number, or some combination, greater than or equal to, less than or equal to, and there is no end point on the other side. So those go towards infinity. Because infinity is not something that you can actually reach, that always uses a parenthesis, because you cannot actually reach infinity. It is not a hard number. So here are some examples of whether you use a bracket, and that's greater than or equal to or less than or equal to, or whether you use a parenthesis. And the key is we always do the smallest number comma the largest number. So if you are going to the left and it's less than, then you're going to have infinity, negative infinity on the left. Well, if you're going to the right, it's going to hit positive infinity. And if your solution is all real numbers, then your notation would be negative infinity to positive infinity to indicate that everything is part of the solution. So in order to get to solving inequalities, once we understand how to write our solutions, we need to then take a look at properties. So we've got the transitive property, which if A is less than B and B is less than C, then A has to be less than C. Addition of inequalities, it's like the addition property of equations, except that it applies to inequalities. It basically says that you can add inequalities together just like you can add equations together. So if you have A less than B and C less than D, you can add A plus C and B plus D, and you'll still have the less than. And then you can also add a constant on both sides, and your inequality will still hold. And then we've got multiplication by a constant. And so we can multiply both sides just like we can with an equation. But with multiplication or division, there is a little caveat here, and that is if your number is a negative. So if you multiply both sides or divide both sides by a positive, your inequality stays the same. But if you are multiplying or dividing by a negative number, then the inequality reverses direction. So if it was less than, it becomes greater than. So it reverses direction if you are multiplying by negative. So that is the one thing to pay attention to, because a lot of people forget that step. And why that is true, let's say I have 2 less than 5. If I multiply both sides, let's say by -1, that would be -2 and -5. Well, -2 is not less than -5. -5 is less than -2. So you have to flip the inequality to get something that's still true. So that's why if you are multiplying or dividing by negative, you have to reverse the inequality. If you're adding a negative, it doesn't matter. It's just with the multiplication and division. Okay, so steps for solving a linear inequality. So step 1 is to use the addition and subtraction properties, just like you would for an equation. The one thing is with an equation, it doesn't matter which side the variable on, but when we have inequalities, the variable needs to be on the left. So always put your variable on the left side and make sure that your numbers are on the right. Once you've done that, then you need to use the multiplication and division properties where you're dividing or multiplying to remove the coefficient. And just remember, if a negative is involved in that step, the inequality reverses. And then once you've done that and you've got x less than, greater than, or something, then you give the answer in interval notation. And if it asks for you to graph, or if it's helpful for you to graph, you can go ahead and do that. So here's one where we're going to solve and graph, so you can see the connection there. So we've got 3x plus 1 greater than or equal to 2x, or 2 plus x. So because I want the variable on the left, I always move my variable first. So I've got plus x, so I'm going to subtract x on both sides. So 3x minus x is 2x. So I have 2x plus 1 is greater than or equal to 2. And now I'm going to subtract the 1 to get that on the right. So minus 1 on both sides. I get 2x is greater than or equal to 1. So now that I've used the addition properties or subtraction properties, I now need to divide, because I need to divide both sides by 2. Because I'm dividing by a positive, I don't have to worry about reversing the inequality. So this is going to give me x is greater than or equal to 1/2. So if we look at this as a graph, I'm going to just put a number line here. I'm going to just put 1/2. And I have infinity and negative infinity. If we are greater than or equal to, so we're greater than, so everything to the right is greater than 1/2, and we can be equal to 1/2. So because we can equal 1/2, that is a bracket. The bracket is used whenever you have an equal to part. And the bracket faces the direction that you were shaded. So I'm going to have a bracket facing to the right because that's where I'm shaded. And then if we go to infinity, that's a parenthesis facing the other direction. They're always going to be facing inside towards what's shaded because we can't actually reach infinity. So our solution in interval notation, now that I've graphed, is bracket 1/2 because that's our left endpoint. Our right endpoint is infinity with a parenthesis. So it usually helps to graph in order to write the interval notation because you can see the connection between the interval notation and the graph versus memorizing what the interval notation looks like based off of the inequality. Okay, so example 2 here, we have a compound inequality. And a compound inequality is when you have two inequalities and they are combined. So instead of having a left and a right side, we have a left, a middle, and a right. The rules apply for this, and we solve it just like we would do anything else, except that instead of doing it to both sides, aka left and right, we have to do it to 3 sides, left, middle, and right. So we have -1 is less than or equal to negative parenthesis x minus 4 parenthesis less than 7. So first, so when we're solving this, we want to have x in the middle because, so we're going to have x, our goal is to have x in the middle for a compound inequality rather than being on the left side. So first I'm going to distribute the negative through the parentheses. So I have -1 less than or equal to negative x plus 4 less than 7. My pen keeps, there we go. Sometimes my pen doesn't like make smooth strokes. Okay, so I want my x in the middle, so I need to remove that 4 that's in the middle with it. And if it helps you, you can kind of highlight so you can see where the middles are if you get lost in the symbols. So I need to subtract 4, and I need to subtract that from the left, the middle, and the right. So you're going to do it 3 times. So that will give us negative 5 is less than or equal to negative x, which is less than 3. I'm going to just highlight here again so you can see that we have a left, a middle, and a right. Now, I want x, I don't want negative x, and so that means I need to divide everything by negative 1 to get rid of the negative. Because I'm dividing by negative 1 and I'm dividing by a negative, I have to change directions of the inequalities. So I'm going to just put little arrows down so that you remember to do that. So negative 5 divided by negative 1 is 5. Now I have to change the direction. Now I have x, change direction, and negative 3. So now I have 5 is greater than or equal to x, which is greater than negative 3. Now generally, we read these left to right with less than symbols. So if you want to read it that way, you then have to reverse the whole thing, sort of like a mirror image. So because we want to have the smallest number on the left. So that's negative 3 less than x less than or equal to 5. And you may be wondering, well, why didn't we just keep the symbols the same and switch the order of the numbers? Well, notice that the order of the symbols also switched. So what was an equal to on the left is now an equal to on the right side. So there's a lot of stuff to kind of keep track of. And so it's best to first reverse the inequalities when you're dividing by a negative, and then, if needed, reverse the entire inequality. You don't always have to do that last step. So that's why I don't try to do it all at the same time, because sometimes you don't need to do that. So now what we have is we're saying that x is between negative 3 and 5, but we can include 5. So I'm going to graph my number line and put negative 3 and 5. And we're saying that x is between there. It's greater than 3, so we can't include 3. But it is less than or equal to, so we can include 5. So if I'm not including negative 3, that's going to be a parenthesis, and it needs to face where I have shaded, so that's a parenthesis. And then at 5, we're including 5, and it needs to face the shading, so that's going to be a bracket facing to the left. And so then in interval notation, we have negative 3, comma, 5 bracket. So you just read it left to right once you have your graph.